correct? Right? And there's no moment. Of course, there's also reaction here. So let's not forget that equals to P plus MB divided by LB. That is the configuration that on the textbook they used. Now, let's take the moment equilibrium at this point, this red point, right here, to see that if we can get the same result. By assuming that summation of moment at this point must be 0, and by assuming that which direction, clockwise or counterclockwise?
Clockwise.
All right, so doesn't matter, right?
Yeah.
Doesn't really matter which direction we assume. So we assume that counterclockwise will be the positive direction. And we take it one by one. The first one is internal moment. Of course, that makes the internal moment to be negative. So it's going to be negative internal moment. The force P plus mb times L over LB, this will be positive. So we have P plus mb over LB times the direction, which is YC. Right? I use Y here, but eventually we call it YC. So let's still use a Y so we have comparison can make.
Is it internal moment positive?
No, internal moment will be negative because we assumed clockwise to be, pay attention to this.
Okay.
All right. And what else? Then we consider this force, we cancel this one. We also have to consider VA, right? And the VA will produce negative moment, right? So it's going to be negative MB over LC times X. Correct?
Yes, we can reach.
Right?
Yeah.
So if we do that, we don't have MB because we are not considering the reference point at point B. I think that's the reason that why we arrived in different governing equations, because we started from different reference points.
No, I got it. Yeah, it can be. Yeah. So we can get positive X on right.
Yes, but as you can see that here, the textbook ignored this term because this is the shear part coming from the column. So they coming from the beam member. So they assume that this term is very small. So we're going to drop it out.
Yeah, now I can get it. Yeah, I can get it. Yeah, I can do it. Yeah. Thank you, Professor.
Sure. So now you know that the reason is because we take different reference point, right?
Yeah.
But the result should be the same.
Yeah. The reason I asked was because you said that there is a question on homework 3 based on this. So to derive it, I was just wondering because if we follow that derivation, then there will be some. Yes.
And the reason I want to go through so much trouble is to show you the very original version on the textbook. But I also have to warn you that from the publisher, they told me that there are about 30 typos in the textbook, the version you have. But Professor Chen and Professor Dewey are too old. They don't have the energy to create a revision of the textbook.
And it was in 1987, I guess.
It's an old book, but it's a very book, and it's good for your training and learning. It's a good textbook.
Yeah. So on the problem, on the homework 2 problem, 4.2, second one, there is a asymmetric loading. There is not symmetrical loading. So on 2P, so I can get 2Ps for those, and then how can I get final, averaging it or adding both of it, it should be a superposition method, right?
Correct. And you can think about this way, right? What's the superposition? Actually, what you need to consider here is only 2 different kind of buckling modes. One is symmetric, the other is asymmetric. Right? And how can you decompose it? And what's the problem? The problem is you have 2P.
Yeah, on the left side. Yeah, on the
that's it?
Top left. Yeah, on the top left there is 2P and nothing else. So I superimpose it by creating PP, and then in the next one P downward, and on the right P upward. So and then we can get P for like both conditions, and at the end, so we should average it, or like because even like I tried from both way, like adding both equations to get P, and then I tried by another way, like averaging both of it, but on the back side of answer it doesn't match. So in the first one, it matches perfectly to the symmetric loading condition.
Okay. And I think the easy answer is when you see the solution, you will see that why your answer is different from the one in the back of the book. I think that will be easy way to answer that.
Yeah, I haven't submitted in this homework because you said that you can postpone it. So I was just thinking that if that asymmetric loading will be in today's lecture. So yeah. But I did solve the first one, the symmetric loading condition, but I haven't submitted it yet.
But I believe that you're heading toward the right direction by using the principle of superposition. And that problem, as you already understood, is...
It will not be a single curvature on the second one because there will be the load like one going up and one going down. So in the book, there is like 4 minus 2. It will be like 4 plus 2. So.
But principle of superposition, most people underestimate its power. And I'll just give you a very quick example because you're interested in this problem, which is 2p, right?
Yeah.
And of course, you can decompose it in whatever the way.
We cannot see the screen.
We cannot see the screen.
Disappeared again?
Yeah.
All right. Like this, right?
Yeah.
You need to know that the principle of superposition suggests many, many numerous possibilities. There's not just one possible combination for superposition. There are infinite numbers of possibilities for superposition. That's why you need to keep in mind. And depending on which solution you feel comfortable, you can do this. You can say, I want to do this, 1p. Right?
Yeah.
And if you can find the solution of this one, you multiply by 2. You add this one to another one. So the question for you is, can you find the solution of this? That's the key.
Yeah.
And of course, you can also superimpose this one into what? So all you need for this one is this one multiplied by 2.
Yeah.
So it's basically this one plus by itself. It's also principle of superposition.
Yeah.
Another principle of superposition is this. I have 2. Then I want to add it with the one that Tech you explained, right?
Yeah.
You can do this. Then you cancel one of them out, you get 2p. But they are not the only 2 possibilities. There are many other possibilities. You can divide it by 2, you can divide it by 3, and you can use other series to add them back. There are many different ways to do it. So here, you already have the solution from this class, from the textbook, which is this one. So you have it. So all you need to do is actually just this one.
Yeah.
Right? And let me re-emphasize the importance of superposition. If you can decompose this 2p into this 2, you can certainly decompose this into more. Right? That opens up another door. And if you get it another structure, you can even superimpose that one, decompose that one into many other combined cases as well.
Yeah.
So it's not just for these 2. You can keep going. It's more like a cascading scheme. All right, so this power you need to keep in mind because it's very, very useful. The only trouble in civil engineering is principle of superposition only applies to linear structures in linear response. That means it will only give you the response if you have any experience in reality in the field. That means what we call surface load analysis. Principle of superposition is only applicable to any prediction of the surface load response. But from our analysis, you know that surface load analysis is what we call ASD. If you use LRFD, this is what we call ultimate load. What does that mean? The ultimate load for concrete means cracking is allowed. For steel structures, that means yielding is allowed. But whenever those happens, you take principle of superposition out of your equation. You cannot use them. So from there, you know that principle of superposition cannot be applied to AORFD analysis. It can only be applied to ASD analysis because ASD is very slow, and that's linear. So that is how you connect stability analysis with your design practice. But of course, you already understand that in this course, we only have time to talk about analysis. We don't have time to talk about design. And that may be another course in the future.
So basically over here on the second picture, we can calculate PCR for both cases and just add it. Like because I guess
yes, because they are linear.
So that will make a large number
yes.
based on the back of the book, but it's just we should be adding it, right? Yeah, to get PCR for both cases. Yeah. Okay, thank you.
Sure.
But because I find this book like there are very few errors, like even like all these answers like perfectly matching. So I was wondering like if I'm doing some mistakes on this question. So I was a little bit hesitant. But might be that answer might be wrong on the back of the book. For this one.
I know that many students cared more about whether their answers are correct or not. And I cannot emphasize, again, I keep saying that tonight. You need to understand that it is not really the points that you're getting. It is the knowledge that you should be getting. If you get A, but you don't have the knowledge, one day you're going to pay the even huge or gigantic price for your mistake.
Yeah, for me, Professor, like, you know, I understand everything you do. And like, you know, I understand like every step you do it. But when you give me a question, sometimes I freeze, like I don't know where to start. You know what I'm talking about?
Your problem is more, sounds more like psychological.
Yeah.
But that's what I told you at the beginning. I was discussing, sharing some thoughts with the rest of the class before we began our lecture tonight. I was telling some students, they joined the session around 6:10. So I was chatting with them. I asked you the question about how do you think about the midterm exam? You know what? Most of them said it was easy. It was easy for them. Why? Because it's open book and open note. But the problem is they weren't very careful. Like when you calculate the EI, you just assume that A is greater than B. You assume the buckling in the plane, so you just take the value. And common mistake is about they take the 200 GPA as KSI. That's not right. So you see, when you look at the mistakes you made, I remember, I don't remember everything, but I remember certain things. I remember the mistake that Tech, if you don't mind me sharing with the rest of the class. Yeah. That's why I make the point, right? You cannot compare PCI. You cannot compare PCI with
I can explain that as well. Right after submitting the scan, I knew that it's here, but I knew that the time is over. Like 2 minutes, I realized that 2 minutes later. So if I had like 5 to 10 minutes, then I could have like fixed those. It was like 13 marks. I got deducted that 13 marks. But I'm not worried about that because I knew that it's here. Right after that, I saw pre-scanning and sent it to you. I saw that here, but I'm not that like I'm not losing hope because I knew what it is.
Yes. My only hope is that every mistake you make on the exams will become a memorable lesson for you in the future.
Exactly.
But the problem that you mentioned is not really something I can help you. That means you haven't taken enough quizzes or exam. The question I asked them is this. I can ask you the same question. Can somebody mute your background? I think that
that's me. Must be okay. I'll mute.
You are in a very noisy environment. All right.
I'm sorry. Yeah, a little bit.